So this design model you're going to see over and over and over in pretty much every Cisco course you run into. So this hierarchy here, the core layer, distribution layer, and access layer, is something you're going to see frequently. And you need to understand the reasons and philosophies behind it. But I'm just going to give you the basics for right now. The access layer is for connecting to our end stations, to our users themselves. From there, we're going to aggregate that traffic up to the distribution layer. The distribution layer gives us a place to provide policy and also gives us a place where we can set our failure domains. So if anything happens at the access layer, that isn't going to spread through the rest of the network. If you've got multiple sets of distribution layer and access layers that need to be interconnected, that's when you build a core. So you have a core of your network that's going to interconnect multiple buildings. Each building would have its own distribution layer and separate access layers inside of a large campus design. But when doing this, you end up with a significant problem. As your layer 2 switches connect to other layer 2 switches in a redundant fashion, you do something that Ethernet really doesn't like, and that's create loops. So here's an example of what happens if you have loops in a layer 2 switch network. If host A sends a broadcast into the network, the first switch that gets it is going to flood it out all ports, as we mentioned when we talked about the flooding process for a switch. The thing is when it floods it to another switch, when the next switch receives it, it doesn't know that if this is the first time it received it or the 115th time it's received it. So it gets that and sends it to the next switch. The next switch floods it out all ports, sends it again, and so on. And the problem is we end up with this never-ending process of flooding broadcast traffic throughout the entire network. Now, I know what you're thinking. Steve, what about TTL fields? Didn't we talk about that with the IP address having inside of not the IP address, but the IP packet itself, having a time to live field? And I even showed you how traceroute worked, how it arbitrarily sets the TTL value to a low value so we can discover routers within a particular network. But there is no TTL field in the Ethernet header. The Ethernet header is a lot simpler. If you go back and look at the 802.3 header, you'll see that there is no space there for a TTL field. So as a transparent bridge, otherwise known as a switch, gets this Ethernet header and floods it at all ports, it never knows whether it's received it once or, again, thousands of times. This creates several different problems. Not only do we have broadcast storms, which coincidentally, broadcast storms don't take all the bandwidth of your network. They actually take all the processing power of the devices that are attached to the network. See, imagine what happens when a host receives 4,000 or 5,000 broadcasts a second. Every single one of those broadcasts at layer 2 has to be opened up to layer 3, which means we have to take it off the network card and pass it over to the processor. The processor opens it up and looks at it and realizes that at layer 3 it's a broadcast, and then opens it up again and hands it over to TCP or UDP processing, at which point it throws it away because it was a DHCP request or some other kind of standard broadcast we might be sending on the network. Those additional processor ticks take time, and they take away from our applications that might be running on our machine. So if you're getting 4,000 of those a second, it's going to seem like your machine is running extremely slow today, and you don't know why. Well, the reason why is we have a loop in the network. Now, the other side of that is we could build the Ethernet network without any loops at all, but that problem doesn't work either, because if there's no loops, we have no redundancy. So what we need is a protocol that's going to stop the loops, and if there's a failure, we can re-enable one of the extra or redundant paths that we have through our layer 2 Ethernet network.